Hello students, myself Himanshu Shekhar Punde and I am a chemistry teacher. Students, many times when we study chemistry subject, we have a lot of problem while the number of equations, reactions, how to memorize that, how we can study the reactions. So for that purpose, I am preparing a separate lecture video on the NCERT chapter number first, chemical equations and reaction. So let's begin. So first of all, do you know what is a chemical equation? We need to think on it. As we all know, in our day-to-day life, there are many reactions are happening. But that reactions are happening in our practical world, in our real world. But how to write those reactions on a theoretical notebook and pen or on a theoretical board? So to write the reactions theoretically or symbolically, we need some formulae, we need some symbols. So what is a chemical equation? It is a symbolic representation of a chemical reaction. Okay. Now the reaction contain mainly two types of things. The one which is called as reactant, reactants or reactant side, and the other one is products or product side. Okay. When reactants, there may be one reactant, there may be two reactants, and there can be one product, two product, etc. So when reactant react with each other, suppose there are two reactants, they react with each other, or one reactant reacts with different conditions, it form a product. So this is the direction of a reaction. Okay. Oh, there are many directions, reversible, irreversible reaction, but that we are going to learn further. So reactants give products. Okay. Suppose, let's take an example. Yes. Now in this reaction, magnesium and oxygen are the reactants and magnesium oxide is the product. But every time we do not write these names of the elements and names of the compounds like this, but we make a symbolic representation. What do we make? A symbolic representation. For example, how we can write that magnesium is shown like Mg plus oxygen. Is this the correct way to represent oxygen? No. Oxygen is always written as like this. Our atmospheric oxygen is O2, which is diatomic, and O3 is a ozone layer. But here, mostly the reactants are reacting with the oxygen, diatomic O2. Diatomic because it contains two atoms. Now, magnesium oxide means MgO. So, here is the symbolic representation of the reaction. But wait, there is one more thing here. We observe here are only one magnesium ion or magnesium element. Here is also one magnesium element. Here are O2, two oxygen atoms, but here only one oxygen atom. So why this happened and how we can solve this? Why this happened and how we can solve this imbalance it is an imbalance. So we need to balance the chemical equation. What do we need? We need to balance the chemical equation. Why? What is the need of balancing the chemical equation? To balance the chemical equation, we are taking some mass of reactants on this left hand side and we are forming some product of reactants on the right hand side. But here, as we know, here are two oxygen atoms and here is only one oxygen atom. So their masses can also be different. So here mass is different, their mass on that side mass will be different. So to conquer this imbalance, we need to know what is law of conservation of mass. Yes, this law we learned in class 9. The law of conservation of mass states that mass can neither be created nor be destroyed. Mass can neither be created nor be destroyed. It means that simply mass of reactants should be equal to mass of products, or total mass of reactants should be equal to total mass of products. Total mass of reactants equal to total mass of products. So how we can manage that? Now let's see how will we balance this chemical equation. So there is a symbolic way for representing this chemical equation. Now we are going to balance. How many? Now let's count each and every atom on the left hand side and on the right hand side. First of all, tell me which types of elements are present. Yes, two types, magnesium and oxygen. So here I am writing magnesium and oxygen. Now on the left hand side, how many magnesium atoms are present? One. On the right hand side, one magnesium atom is present. On the left hand side, how many oxygen atoms are present? Two. And on the right hand side, how many oxygen atoms are present? One. So here we need to balance this equation. Now suppose I want to make this oxygen 2 and 2 equal. So what I can do? I will multiply this 1 by 2 so that I can get 2. But here if I want to multiply this oxygen by 2, I want to multiply this entire compound. So what will happen? It will happen like this: Mg plus O2, it will give 2MgO. So now how many elements of magnesium we are observing? Magnesium 1 on the right hand side, 2, oxygen 2, 2. Now here two magnesium atoms. Here also I want two magnesium atoms. So what I can do? I will multiply this 1 by 2 so that I can get 2. And here the magnesium will be multiplied by 2. Now check the reaction whether this reaction is balanced or not. Two magnesium atoms, two magnesium atoms, two oxygen atoms, two oxygen atoms. So now we can say this is a balanced chemical equation. Now we will solve one more example and we will proceed towards the types of chemical reactions. Now our question is, sodium reacts with water to form sodium hydroxide and hydrogen. So this is our question. Sodium reacts with water to form sodium hydroxide and hydrogen. Now look here carefully, which are the reactants and which are the products. Sodium reacts with water. So sodium and water are the reactants. So I am writing there. I am writing these two elements on the reactant side. So sodium symbol is Na plus water symbol is H2O. It is giving sodium hydroxide NaOH plus H2, that is hydrogen gas. Again, hydrogen is also diatomic gas, it exists as H2. Okay. So here I am writing Na plus H2O, which gives NaOH plus H2. Now again I am going to count the sodium atoms, hydrogen atoms and oxygen atoms on the both sides. So let's I am going to write Na, H and O, LHS and RHS. So how many sodium atoms on the left hand side? One atom. How many sodium atoms on the right hand side? One atom. How many hydrogen atoms on left hand side? Two atoms. How many hydrogen atoms? One, two, three atoms. And how many oxygen atoms? One atom, one atom. So this is the LHS and RHS we have written. But to make things simpler, can I write these three like this? 1 plus 2. Why? One oxygen here, one hydrogen here, two hydrogens here. So I am writing it like this. Because whenever I will multiply this NaOH, only this one will be multiplied. And whenever I will multiply this hydrogen, H2, this two will get multiplied. So what do I need? I need these two hydrogen atoms. Okay. So what I will do? I will simply multiply this one by 2. So 1 into 2 will become 2. So here I need to multiply this NaOH by 2. So here Na also becoming 2 and oxygens are also becoming 2. Sodium are becoming 2. Oxygens are becoming 2 and hydrogen 2 plus 2 becoming 4. So now here I want to balance sodium atom Na. Again I will multiply 1 into 2. It will become 2. So here 2 Na. This hydrogen is 2. This hydrogen has 4 atoms this side. This is 1, this is 2. So what I will do? I will just simply multiply this H2O by 2. So what will happen? 2 into 2, 4 hydrogen atoms and here 2 oxygen atoms. Now all the reactions, all the elements in the given reaction are according to the law. Which law? Law of conservation of mass. Means the reaction can be said as a balanced chemical reaction. So what we can say? This is a balanced chemical equation. This is a balanced chemical equation. Now there is one more thing. Sodium is taken, water is taken, sodium hydroxide is taken and H2 is also taken. But what are about their states? What is the state of sodium? What is the state of water? What is the state of this NaOH and what is the state of H2? Yes, do we know about physical states? What are the physical states? The physical states are solid, liquid and gas, gaseous, solid, liquid and gaseous states. So now we are going to learn about writing the physical states of the reactions. writing the physical states of reactants and products. So S will be for the solid state, L will be for the liquid state, G will be for the gaseous state. And there is one more state, or there is one more possibility where we can write this thing, which is called as AQ, aqueous state. Aqueous means anything dissolved in water, that is called as aqueous solution. Aqueous means dissolved in water. So when I take sodium metal, it is in the solid state. And as we know, the sodium reacts with cold water. There is a thing called reactivity series that we are going to learn further. But sodium reacts with cold water, and sodium reacts with water in its liquid state. No need to take gaseous state. So sodium plus plain simple water, liquid, plus NaOH plus hydrogen gas. So it is simple, solid, liquid, gas. We understood how to write solid, liquid, gas. But when NaOH, sodium hydroxide solution, the solution is nothing but aqueous solution because it is dissolved in water. So this is the reaction. This is the balanced chemical equation where we have already written the states, physical states of the reactants and products. So 2Na solid plus 2. How we can read that? 2Na solid plus 2H2O liquid. It gives 2NaOH aqueous plus H2 gas. Or sodium metal reacts with water. Sodium metal in its solid state reacts with water in its liquid state to produce aqueous solution of sodium hydroxide and liberates hydrogen gas. So whenever it liberates hydrogen gas, we can show it like this. Is it clear? Now we are going to learn about different types of the chemical reactions. Now I am going to write one reaction. What we are going to understand, there is something new in the reaction. The reaction is okay. Now see in this reaction, what is happening here? These two reactants are in the gaseous state and the product forming is in the liquid state. So let's imagine gas. Gases have intermolecular distance. One molecule of gas is here, another molecule is here, another molecule is here, and the liquid particles are closer to each other. Liquid particles are closer to each other. So gas particles are away from each other and liquid particles are closer to each other. How it is happen? Because the gas particles are being compressed or are being pressurized. So this is the reaction condition. The topic is writing reaction conditions. So ATM is the short symbol, atmosphere pressure. Pressure is in measured in atmosphere. Okay, so this is the 340 atmospheric pressure which is applied to carbon dioxide and hydrogen gas, which forms CH3OH, which is called as methyl alcohol or methanol. So here is the writing reaction conditions. So writing reaction conditions contain writing pressure, temperature. Temperature most of the times in reaction measured in degree Celsius or Kelvin. Pressure most of the times atmosphere or bar. Most of the times we use atmosphere only. And the third thing is catalyst. What is a catalyst? Which boosts up the chemical reaction without actually involving in the chemical reaction. So catalyst, which catalyst is used? Okay. So these are the pressure, temperature, and catalyst. These are the reaction conditions are written here above the arrow or below the arrow. Now, what are the types of chemical reactions? What are the types of chemical reactions we are going to study? Yes, there are many chemical reactions, such as combination, decomposition, combination, decomposition, displacement, double displacement, oxidation, and reduction, etc. We are going to study in this chapter. So first of all, and also two more reactions are there which are called as endothermic and exothermic reaction. So we are going to study this type of reactions. First of all, we are going to learn about combination reaction. Combination reactions. Combination reactions. What will be the definition of these reactions? Combinations, to combine. So when two or more substances combine to form one product, when two or more substances combine to form one product, it is called as combination reaction. It is called as combination reaction. Now just rewind the video and the reaction which we have written earlier. Can we say that is the type of that type of reaction is combination reaction? What was the reaction? CO2 plus 2O2, it gives CH3OH. Yes, why not? Two or more substances combine to make one product. So that is called as combination reaction. So I am writing the same example here. What we have written earlier, CO2 in the gaseous state plus O2, or it was H2. It forms CH3OH in the presence of 340 atmospheric pressure. So this is called as combination reaction. Okay. Now the second type is called as decomposition reaction. It can say, we can say that it is the opposite of the combination reaction. What we can say, it is the opposite of combination reaction. What was happening in combination reactions? Two or more products forming two or more reactants forming one product. Now in decomposition, one reactant will form two or more byproducts. One reactant will form two or more products or simpler compounds. So, what is the definition of decomposition reactions? Breaking up of a single compound either into elements, separate elements, or a simple substance which cannot be combined together under given conditions. Why we have written? We can combine them afterwards. We can again, suppose we are decomposing any element, any compound into simpler substances and elements. Again, that elements can be combined, but that will be combination reaction. So, under given condition or under certain conditions, that simpler substances cannot be combined together. So, that is called as decomposition reaction. Uh, Breaking of single compound are called as decomposition reactions. Now let's take example of this decomposition reaction. Let's take example of ferrous sulfate. So this is the reaction of breaking of ferrous sulfate into ferric oxide. So here there is only one element, or what we can say a single compound, which is breaking into simpler elements, or which is breaking into elements or simpler substances. So it is forming ferric oxide, which is in solid state, and SO2 and SO3 gases are liberated. Now one more reaction I am going to write on the board. You have to identify that is a combination reaction or a decomposition reaction. Okay, and you have to also tell me the reaction is balanced or not. So where you can tell me? Yes, in the comment box. So you must answer, pause and answer. So the reaction is limestone on heating gives quicklime and carbon dioxide. So my dear smart students, I know there is no need to write the reactions. You have already identified the type of reaction. Why? Because limestone is a one single compound and it is forming two different simpler substances, quicklime and carbon dioxide. So it is none other than decomposition reaction. But still we are going to write the chemical reaction, and if it is not balanced, we are going to balance that. One confusion I realized many students make about this limestone, quicklime, and what was one more thing that is called as slaked lime. So I am going to write here to avoid the confusion. So limestone is nothing but CaCO3. It is called as limestone. So it is called as limestone. It is in the solid state limestone, or its chemical name is calcium carbonate. This is called limestone. Then quicklime is CaO, which is again in solid state CaO, which is called as quicklime. Its chemical name is calcium oxide, quicklime or calcium oxide. And another thing is CaOH twice, which is called as slaked lime calcium hydroxide. Its chemical name is calcium hydroxide. So these are the three things we are going to understand about the calcium, carbon and oxygen, and hydrogen is also present. So there are two or three types of reactions by which contains these compounds, interchanging of these compounds, and many reactions involving these compounds also. So you must need to understand these various names of these compounds. So now our main reaction is limestone or calcium carbonate on heating gives quicklime CaO plus CO2 which is in gas. So here I can write it like this heat, or I can write it heat like as delta. In many books, reference books or textbooks, it is like written like this. It is called a symbol delta which is used for heat. So calcium carbonate on heating gives quicklime and carbon dioxide. So this is the example of decomposition reaction. This is the example of decomposition reaction. And the next reaction we are going to identify. There are next two types of reactions. One is exothermic and another one is endothermic. Now, what is this exo-endo reactions? We are going to understand, and how to avoid the confusion between these exothermic and endothermic reactions. Now, all of you must have observed what we can say exhaust fans in our houses. Exhaust fans. So, what is the task of that exhaust fan? It throws the heat outside our house, or it absorbs the heat. It absorbs the heat from outside and keeps us warm. I am repeating my question. What is the task of exhaust fan which is placed in our kitchen? Does it throws the heat outside the kitchen, or does it absorbs the heat from the outside environment into our room? Yes, the first option is correct. What it does, it throws out. Exo means throws out, throwing out the heat of the reaction. So what are called as exothermic reactions? Heat is throwing, or heat is thrown, or heat is evolved. Heat is evolved. Suppose this is a chemical reaction. Here chemical reaction is happening. So heat is being evolved. But in the case of chemical reactions, by evolution of heat, the temperature of the reaction also increases. Temperature also increases. Suppose we are mixing two reactants. So initially their temperature will be low, but when we mix the two reactants, they will, if they are forming exothermic reactions, the overall temperature of the compound will be increased. Means two separate reactants, suppose A and B, are mixed to form C. Suppose we are mixing A and B, so the temperature of A and temperature of B may be low initially, but when it forms C, it is forming exothermic reaction, so its temperature will be little bit higher. Now we are going to learn about endothermic reactions. Heat is absorbed. Heat is absorbed. So what will happen? Heat is absorbed. Heat is being absorbed. So these are the two types of reactions which we are going to learn. Now what are the examples of these two reactions? Now, what is the meaning of this reaction which I have learned, which we have learned earlier? Calcium carbonate decomposes into calcium oxide plus carbon dioxide. This was the reaction we have learned. But it takes the heat. We need to give heat. We need to give heat to the reaction. So it takes up the heat. It means it absorbs the heat. So it is the type of endothermic reactions. And what will be the type of exothermic reactions? Burning of natural gas, that is methane gas plus 2O2. Now I am writing it in the balanced form to form CO2 plus 2H2O. Now the burning of natural gas. This is the reaction where heat is being released. So here one more thing is written, heat is released. So this is the type of exothermic reaction. So this was the first video of our chapter chemical equations and reactions. I hope you have enjoyed the video. You have learned many important things from this video. So we will, if you have any doubts, you can put it in the comment box. Thank you so much. We will be meeting soon in the next video for the next remaining topics. Thank you so much.